Hello and welcome to HCI 509, Research Methods and Statistical Analysis. Today, in Lecture 10, we'll talk about t-tests. So let's get started. First of all, let's talk about comparing means, and we'll start off with a couple of questions. The first question is, a researcher is planning to conduct an experiment to evaluate the effectiveness of two search engines. If they adopt a between-group design, how many groups of participants will they recruit? How many groups? Two search engines. Okay, are you ready? The answer is two groups because the between group each will use a single one of the search engines. And now let's go on to question 2. A researcher is planning to conduct an experiment to evaluate the effectiveness of two search engines. If they adopt a within-group design, how many groups of participants will they recruit? Are you ready? The answer is one group, and each participant will use both search engines. So again, that's testing your knowledge about between-group and within-group designs. The third question. In both examples, the objective is to compare the performance measures of the groups or conditions to find out whether there's a significant difference between the two search engines. True or false? It's true, because that's what we're trying to observe with our research experiment. Now for the fourth question. It's okay to compare the means of multiple experimental conditions and claim a difference exists as long as the means are different. True or false? Are you ready? The answer is false because remember the height examples from lecture 4 where we were talking about the means of 3 different men and 3 different women? We said that 3 women were taller than the 3 men. So due to the variances in the data, we can't directly compare the means of the multiple conditions. We also have to consider the variance. So this leads us to the main topic, significance tests. Statistical significance tests evaluate the variances that can be explained in the independent variables and the variances that cannot be explained by. So the significance test will suggest the probability of the observed difference occurring by chance alone. So if the probability that the difference occurs by chance is low, meaning less than 5%, we can claim with fairly high confidence that the observed difference is due to the difference we observed and the controlled independent variables. So let's talk about some different types of significance tests. The most common ones that we use to test the means of multiple groups include t-tests and ANOVA, which is analysis of variance. The t-test is a simplified ANOVA and only involves 2 groups or conditions. So most common are the independent samples and the paired samples t-tests, which correlate well with the between groups and the within groups test. And we'll see more about that in just a minute. So when a study involves more than 2 conditions, we have to use ANOVA. And this includes a lot of different types of designs. So one way, factorial and repeated measure ANOVA. And we have to use ANOVA for a split plot design. Remember the study where I was looking at age, gender, and race in determining whether they were more likely to be called for a job interview? So this involves 3 factors. And with each factor, we have multiple conditions. So we had to use ANOVA. A t-test just wouldn't do in that particular situation. Here's a nice summary, and I think you'll come back to the slide several times when you're trying to identify the right approach. One of the challenges of any kind of statistics is knowing which test to do when. In fact, I always have to give a little bit of thought to this. So in the leftmost column, we see between group, within group, and then we have a between and within group or split plot. You see in the second column, it's the number of independent variables, 1, or 2 or more, and each condition for the independent variables. So if we have a between group study and we have 1 independent variable and 2 conditions for that independent variable, we can use an independent samples t-test. And again, that has to do with the between group study. If we have a within group study, we have 1 independent variable and 2 conditions, we'd use the paired samples t-test. But you see, in every other condition, if we have more than 2 conditions for each independent variable or more than 1 independent variable, we've got to use a type of ANOVA, either a one-way, factorial, split plot, or repeated measures. So first we'll start with the t-test. Now the t-test has a pretty interesting history. It's also called the student t-test, and sometimes it's called the student test statistic or the t-statistic. And it gets its history from its introduction back in 1908 by William Seeley Gossett. Now, William Gossett was a chemist for the Guinness Brewery in Dublin, Ireland, even though he was an Englishman. And he came up with this test because he was working to find out how the amount of barley in the brew would actually affect the results. And the t-test was designed for small samples, and there weren't any statistics out there at the time that dealt with how to manage small sample sizes when you're doing some kind of statistical hypothesis testing. So he is considered the founder, even though others had done work in the field prior to him. So let's talk about the overview. The t-test is really the most widely adopted statistical procedure for comparing 2 means. Different types of t-tests are adopted depending on the design of the study. So when you have 2 groups being compared that are presumably unrelated, meaning they are independent, we can use an independent samples t-test. So this would be your between groups study. Every participant is either using 1 browser or 1 search engine or 1 particular tool, and you want to see how those values compare. If you have the same set of people using both search engines or both browsers or both tools, you can use a paired samples t-test. And this is done with the within group study. Now, typically, this is considered a more powerful test. The results are better than with the independent samples. But if you only have the independent samples to work with, that is still a very strong test. Let's look at a case study. Suppose we want to investigate whether the use of a specific word prediction software has an impact on typing speed. So our null hypothesis would be there's no significant difference in the task completion time between individuals who use the word prediction software and those who do not use that type of software. So this null hypothesis can be investigated through 2 different designs. So let's look at a case study. Suppose our goal is to investigate whether the use of a specific word prediction software has an impact on typing speed. So our null hypothesis would be there's no significant difference in the task completion time between individuals who use word prediction software and those who don't use the software. So we can investigate this through 2 different designs. The first is the independent samples t-test. With this, we would recruit 2 separate groups of participants. One would use the standard word processing software only, and the other would use the word prediction function software. This would be a between group design because each group is using only one of the 2 tools. So if we used a random sampling method, the 2 groups are presumably independent from each other. See, that's why random sampling is important. And therefore, we'd use the independent samples t-test for this type of analysis. So in JASP, which is a tool I'll provide some information about, it's a nice, easy to use tool to do these kinds of tests. The data points of the 2 groups should be listed in the same column. An additional column needs to mark which each data point belongs to, because we have two groups. One is using the word prediction software, the other one is not. So we need to tell the software which is belonging to which group. This might be how we would look at the data. Now, each condition has 8 participants, and the coding column, notice the far column, tells whether it was with or without word prediction. And again, we can choose whether one means they use the word prediction software, which is how it's coded here, or we could switch it as long as we knew what that coding meant and then we were consistent. And notice only the third and fourth column need to be entered into the software. So here we have the task completion time and the coding. It's really important for us to get that correct, because if we mistake a coding of a 1 for a 0, it could change our results. Let's take a look at a paired samples t-testing. This is an alternative strategy to the same kind of test, the word prediction software study. So we recruit one group of participants, and each participant is going to complete typing tasks under both conditions. So this is a within group design. And since the data points contributed by the same participant are related, a paired samples t-test should be used. So how we would enter this into JASP is, because they're the same participant, we don't have to have that coding column. What we need to do is we need to have the scores for no prediction and with prediction. So you can see here we have one participant for each row, and they have 2 different scores. Now, we're going to have to randomly assign whether they do with prediction first or no prediction, but we're going to put them in the columns that correspond to the type of software they used. So we have 8 participants, and this is how we'd enter the data. So we only need to enter the second and third columns. So how are we going to interpret these results? There's something called a t-value, or sometimes it's called a t-statistic. The t-tests return a value which is represented by a lowercase t. The larger t-values suggest a higher probability of the null hypothesis being false. So the larger the difference in mean and the smaller the variance of each set, that's going to suggest that there's a true difference between the two due to the prediction software. So the higher the t-value, the more likely the two means are different. So we need to look at a confidence interval. Normally we use a 95% confidence interval with significance tests. Now again, I rarely see this greater than 95%. I see it smaller, like with medical studies, and in physics they use a really large confidence interval. So their p-value is like 0.000003. So any t-value that's higher than the corresponding t-value at the 95% confidence interval. So we're comparing 2 different t-values. And that's going to suggest that there's a significant difference between the participants, or in this case, between the software tools. So the between users who use word prediction software and those who don't. So most statistical software will generate a summary table for the results. They have other results that examine the data distribution, and they have descriptive statistics like we talked about last lecture. So if we ran an independent samples t-test, and that's a what? That's a between group study. And remember what that means. We have each group of participants only using one of the particular software tools. If we have this type of test using the data set provided in our first example, we get a return t-value of 2.169, which is higher than the t-value for the specific degree of freedom. So degrees of freedom is the number of participants minus 1. So remember we had 8 that used one tool and 8 that used the other. So that means we have 16 participants, and we have 16 minus 1, or 15 degrees of freedom. So that is one input that's going to determine what t-value we compare against. And the 95% confidence interval, we get 2.131. And remember, ours from our study is greater than the 2.131. This implies that we would reject the null hypothesis because we have a value that's greater than what we would see at the 95% confidence interval. 95% confidence interval means P equals 0.05. Let's talk a minute about degrees of freedom. That is an estimate of the number of independent pieces of information that went into calculating the estimate. So we had 16 participants in that between group study. And what that means is we have 16 minus 1 pieces of information. So it's not quite exactly the same as the number of items. It's the number of items minus 1. So when we report results, we can report this as an independent samples t-test. We have to talk about what type of test suggests that there was a significant difference. The reason why we say significant difference is because our t-value was greater than the t-value at our tested threshold. In the task completion time between a group who used the standard word processing software and a group who used the word processing software with the word prediction functions. And notice how we report it. So we put a lowercase t, we put the degrees of freedom in parentheses, and then we put equals and the t statistic or the t value we got, and then the p value we tested against. So the p is less than 0.05 indicates that we were testing at the 95% level of confidence. So notice the t value and the degrees of freedom and the level of significance all need to be reported. So let's talk about the difference between two-tailed t-tests and one-tailed t-tests. So in the previous examples, the hypothesis doesn't specify the direction of the difference. Remember what our null hypothesis was. So this implies that the use of word prediction software may improve typing speed, it may reduce typing speed, or have no impact. So we have three possibilities, but we haven't specified that the word prediction software may improve it or it might actually harm our results. This characterizes a two-tailed t-test. When we have this, half of the alpha, remember we have 0.05, so half of this, or 0.025, is for testing the significance in one direction, and the other half is in the other direction. So in a one-tailed t-test, we specify the direction of the difference. So we can say that the word prediction software will improve typing speed. So our hypothesis would be individuals who use word prediction software can type faster than those who don't. So that would be our alternative hypothesis. For this case, we'd only look at one tail of our t-test, and we call this our alpha. So this would be 0.05, but only in one direction. The use of the word prediction software is expected to either improve or no impact. We're not even looking at whether it's going to reduce the typing speed. In this case, if using a significance level of 0.05, a one-tailed test allots all of its alpha to testing the statistical significance in one direction of interest only. Thank you, and I hope this has given you an overview of t-tests, and we'll look at ANOVA in the next lecture. Thanks, and I'll see you next time.